Question 4 says, for what values of x is the inverse of g multiplied by the derivative of g divided by g will be less than or equal to 0? So usually with these questions that deal with inequalities and graphs, it's a good idea to section up your what do you call this, your plot, such that you can decisively see each area that will be a key area. So I know that's a lot of words, but basically everywhere where your graph goes from negative to positive should be highlighted, all those x values where there is that kind of change. So if we do that for this graph, we see that at 1, take this vertically down, something like this. This is a key point. We can also discuss this being a key point since it's the asymptote for our graph of G. So we have two regions. In this region, or next to, from this point going to the left, G of x does not exist. You can see G of x only exists to the right of this. So we are not even going to consider this side because our graph does not exist that side. Then the other thing that we're going to look at is this value over here, the derivative of G. So if we look at G was a logarithmic function. So its first derivative across all its x values, you will notice that all of them will be positive. If you approximate the tangent at any point on this graph, it will always be positive. That's one way of understanding it. The other way of understanding it is that this graph is only increasing as x increases. So this value will always be positive. And if it's always positive, then it doesn't really help us in our situation where we are looking for the x values that will allow the result of this to be negative. So if it's doing nothing, then we can reduce our considerations to be g, the inverse of g over g itself, where this is less than or equal to 0. So the only other regions to consider is in between here and then further on. If we start with further on, we see that both g is positive. So for all of these x values from 1 onwards, g is positive and it's returning positive y values. And the inverse of g, which is the exponential function, is also returning positive values at values of greater than 1. So it means this region won't apply because it will just be positive over positive, which will be greater than 0. And we don't want that region. So hopefully it will be the last region we need to consider, between 0 and 1. Between 0 and 1, we see that the log graph is returning negative values for these x values. So if I pick a x value here, it returns a negative. If I pick a x value here, it returns a negative. But if I pick those same x values on this graph, it's returning positive values. Here it's returning positive values. That means between 0 and 1, our inverse is positive, but our g will always be negative, and positive divided by negative will be less than 0. And if we consider it at 1, we'll find that it will also be 2, specifically at x is equals to 1, we'll get 2 on top, and then at the bottom we'll get 0. But we don't want that situation because we cannot divide by 0. So we cannot include 1 in our answer. We also cannot, oopsie, we also cannot, okay, we don't need that line. We also cannot include the asymptote, the y-axis. So x is equals to 0 is not included in the answer. X is equals to 1 is not included in the answer. Therefore, you can describe your region as x has to be strictly between 0 and 1. And that's how you would write your answer. These are the values of x that satisfy this condition.